This is example 8-4, where we'll do a dimensional analysis of flow through a pipe. So in this case, we're given that the pipe has a flow of Q, and it is supposed to be a function of the density rho, the gravity G, and the diameter of the pipe. All right, so let's start. We can say we have our function of Q, rho, G, and D, right? Those are all our unknowns, is equal to 0. That means we have 1, 2, 3, 4 variables. Which means that our n is equal to 4. Now let's find our m. So to do that, we need to find where all the primary dimensions are. So for Q, we know that's a volume per time. So that would be length cubed, t to the minus 1. Then for rho, that's a density, right? That's mass per volume. So that'd be m L to the minus 3. G is a length per time squared. And then the diameter, of course, is just L. So that means all 3 primary dimensions are present. All 3 primary dimensions. That means m is equal to 3. So we get n minus m is 4 minus 3 is equal to 1 pi term. So a single one should get us through. All right. Now, in our case, we want to get everything in with regards to Q, so we take Q as the outside one. So we'll say pi is equal to rho to the A, G to the B, D to the C, and then Q. So that means we start with rho. So that was mass per length cubed to the A. Then that was G was length to the time squared. And that raised the B power. Then D was just a length to the C power, and then our Q, which is just a length cubed, the volume per time. So if we organize that as MLT, let's see, M is only at A. L is minus 3A plus B, right, to the 1, plus C, and then plus 3. And lastly, T is minus 2B, and then minus 1. That means we can write our set of equations where we have M is just 0 is equal to A. That's always good. That one falls out. L is the long one, so we have 0 is equal to minus 3A plus B plus C plus 3. And then for T, we can say that was 0 is equal to minus 2B minus 1. Then, so from that we can say, of course, A is equal to 0. We can say B All right, if we bring that over, we'd have 2b is equal to minus 1, so we'd have b is minus 1/2. And then c. C is then, what do we get? So bring c is Louis here, so it would be 3a minus b minus 3. And what is that? A was 0, so we have 1/2 minus minus, so plus 1/2. Minus 3 is minus 2.5, so minus 5/2. All right, so now we have all of our coefficients. We can say pi is equal to, we had gamma, rho was first, and a is equal to 0. Then we had g, and that is b. B is equal to minus 1/2. And then we have the diameter d, and that is equal to minus 5/2. And then, of course, we have, lastly, we have q. So if we rewrite that, right, q is the only one that has a positive coefficient. Both of these are halves, so we can do the square root. So it'd be g, and then this is, of course, to the 5th power then. So that would be our relationship, right? So we can write that as our function. We can say f of q over g d to the 5th is equal to 0. So then we can say q is going to be some constant alpha times g times d to the 5th power. Maybe over here, alpha is a constant to be determined, oops, it's not going to fit, through experiments. All right, so cool. So we've now found what the relationship is between the flow rate Q and the density, the gravity, and the diameter. All right, so this is the and we actually see that the density completely falls out, right? So the density does not have an impact on this, on the flow rate in this case.